Okay, so now we are recording. So welcome everyone. And today our topic is anti-fragile software design. I'll share my presentation. I hope you like it. Is this one? Okay. So okay. So the first we need to define what is this concept of anti-fragile and how it applies to software design. Can you have more information about this on my blog that you should know? I ask everyone to be on mute. If you're not speaking, please be on mute because there is lots of noise. Okay, so put you on mute. Okay, so now we are okay. So this is a bit old. This is from the time I worked at Pontis. So this is 10 years ago. So this work is based on a very famous book called Antifragile that was written by Nassim Taleb. Nassim Taleb is a very interesting person. He's originally from Lebanon. He's kind of an economist and also philosopher. And he reads a lot and he also writes a lot. He had several other famous books like The Black Swan. You probably heard about this book, The Black Swan. It was a movie also. And he also wrote a book called Fooled by Randomness. And in this book, that is my favorite one, Nassim Taleb describes a new concept. He's not just defining a new word. It's really a new concept. And I think it's amazing that in the 21st century, someone can create a new concept. I think it's amazing. And then the first thing he explains is the difference between being fragile, robust, and anti-fragile. So something that is fragile are things that are exposed to volatility. So that when there is volatility, this causes harm. This may damage them. So for instance, here you see this glass that was broken because it fell or something, or some impact. Okay, what is volatility? Volatility is any sudden change in condition. Anything that is not stable is volatile. And then you have the robust things. Robust things are very immune to volatility. So the conditions may change a lot and they remain the same, like this stone. And this stone for thousands of years can look exactly the same stone. And now Nassim Taleb creates this concept of the anti-fragile. Anti-fragile are the things that enjoy volatility. So that volatility is good for them. It's beneficial to them. So for instance, anything that can evolve. If there is something that can pass evolution, so the volatility is good for the evolution because it's helping the species to become stronger. Also, a nation may be volatile. A nation may be anti-fragile, and the people may be anti-fragile. A culture may be anti-fragile. Okay? So the fragile things, they break. They may suffer process of erosion, and they may deteriorate. The robust things, they are always the same. They don't change. And the anti-fragile things, they are evolving, they are improving, they are getting better. Okay, so these are the three different possibilities. And the anti-fragility is not resilience and it's not robustness. Okay, something that is resilient will resist the impact and stays the same. The anti-fragile will get better. As you see here in this image, which I like, you see a very old temple built with stones, and then a tree growing on it. Okay, so I like this image. And this is related to decision making. The idea is that in practice, this is not just philosophy. Okay? We are not talking about philosophy. We are talking about something that has practical applications. So instead of trying to forecast the future, we should try to make things that are anti-fragile. Okay? And this is aligned with this agile principle that we discussed, responding to change instead of following a plan. Okay, so if you see on time in the timeline, the things that are close to us in the timeline, they may be predictable. So perhaps you can predict where you'll be next week. Then as you get far from the present on the timeline, things became very uncertain, and where you are very far, they are totally unpredictable. And today, this horizon of predictability is very close to us. And because the world is changing so fast that even regarding a few months, it's difficult to make a prediction. Okay? And I'm not only talking about Israel. Today, in any country, it's difficult to make predictions. There is lots of instability. And if I am in France, I don't know what's happening 6 months from now. If I am in Canada, if I am in Italy, if I am in England, if I am in Germany, I don't know what's going to happen 6 months from now.
Can I say something?
Now you can.
Niels Bohr once said, making prediction is very hard. Making a prediction for the future is even harder.
Excellent. Thank you, Uri. Okay, so now we have 3 people from Margin. We have from Margin Dennis, Uri, and Srushti, and we have from DoYou, George, Eugene, and Paula, and Yuval. And there are some people missing from DoYou today because they are visiting Google Office, but they will see the recording. Okay, so because it is so difficult to predict what is going to happen in the future, we adopt a different approach. We say we are not even trying to make a prediction. We'll just try to be resistant, resilient, robust, and if possible, anti-fragile. And so it's a different approach. I don't try to make a plan. I just will try to be strong. Okay, I will just try to have tools, to have skills, to have resources. You see, I'm not trying to plan, oh, what am I going to do in 5 years from now? What is my plan 5 years from now? I have no plan for 5 years from now. I just want to be strong. I want to be healthy. I want to have money in the bank. No, I want to be a smart person. I want to learn new skills. That's my plan. So whatever happens in 5 years from now, I will be ready, hopefully. Okay, I will just need to be stronger than I am now. Okay, that's the approach. And then, how does it apply to software design? Okay, we're talking about, we are software developers or data scientists. So in the case of software systems, this volatility are the changes over time that we need to change the system. And these changes are unavoidable. We cannot avoid them. And this is one of the Lehman laws of software evolution. This is the law of continuing change. A software system must be continually adapted or it becomes progressively less satisfactory. So in other words, a software system, if we don't change it, it will not be useful. For the software system to be useful, we need all the time to change it. Okay? So this is one of the laws of software evolution. By the way, Lehman was a Jewish researcher, and I know his son. Now there are 2 kinds of changes. There are functional changes and there are non-functional changes. What are functional changes? Functional changes are new requirements. or modifications in the requirements. And they have an impact on the behavior and the functionality. And they may also have an impact on the structure. And non-functional changes are about quality. They are not about functionality. So normally they're a result of refactoring, and the goal is to reduce what's called technical debt. Now, perhaps I'm using some new concepts for you, refactoring technical debt. I cannot explain now, so please take note. If you don't know what is refactoring, if you don't know what technical debt, take note and you study later. Okay, but the non-functional changes, they should not affect the behavior or the functionality. They should affect the quality and the structure. Okay, so these are the main two kinds of changes. Now, what strategies can we use to help our systems become more robust, more resilient, and even anti-fragile? So one strategy is called the Barbell Strategy, which is a word that I didn't know before I read the book, which is this object here. And this object, it has two extremes. You see, it's an interesting object because it is very heavy. This is a very heavy object, but the weight is on the extremes. It has on the extreme left and extreme right. So interesting concept to put the weights on the two extremes. And it is more robust than having all the weight on a single place, right? So let's see how it applies in practice. So for instance, in investment, if you are an investor, you have money you want to invest, you can have one extreme that is low risk and another extreme that is high risk. So the low risk is having cash in the bank, and the high risk is to do something that is speculation, like the stock market, or something worse like cryptocurrencies. Okay? So you can take your money and divide it in these two halves, one safe and the other risky. And it is considered to be a good strategy because what the part that is safe, you are not going to lose it because it's safe. And the part that is speculative can generate you a very nice profit because it is risky. High risk, high profit. So this is a very concrete example. Now, in the case of software, we can ask, what is the equivalent? So this now is something that is my suggestion. It's not from his book or any other book. This is my suggestion. The answer is having abstractions. When we organize our software system using abstractions, we are having two streams. We are separating one extreme that is abstract from another extreme that is very concrete, which are the implementation details. You understand these two extremes? We have an abstraction and a concrete implementation detail. Okay, so the abstract elements, they are robust. They should not be easily affected by changes. So if you did a good job creating your abstractions, they should be very resilient. And the concrete implementation details, they are fragile. So if you change the requirements, you have to change the implementation details. So the goal is that when we need to change the requirements, this does not affect the structure and organization, and they preserve all the high-level abstractions, and they need to change only the low-level concrete implementation details. Okay, do you like it? Any comment? Okay, so this is a very concrete strategy. Okay, it's a very easy to implement a strategy. It's almost, I would say, almost intuition. It's my intuition that I should do this. Now I'll give you 6 examples. Information hiding, encapsulation, the open-close principle, test-driven development, inheritance hierarchies, and frameworks. Okay? Moving from the concrete to the abstract. Let's start with information hiding. Information hiding was defined by David Parnasse, or in English, David Parnasse, in the 70s. Okay, so this is 50 years old. Okay, this is older than you, with the exception of Alex. Alex is older, but all the others, this is older than you, right? A bit older than Yuval. Yuval, this is a bit older than you. This is 50 years old. Okay, it's the age of your father. How old is your father, Yuval?
I think same as you. What year were you born?
I am 1970.
My father 74.
74.
Yeah.
Okay, so your father.
I'm a dinosaur because I was born in 58.
58. Wow. Wow, you are very
Wow,
old,
yeah.
Alex.
I
Yeah.
wrote my first program in 1972.
72. I was 2 years old. When you wrote your first program, I was 2 years old. Okay, so information hiding is in the 70s, and he wrote this, that every model should hide some design decision from the other models. And he talks already by interface. Did you know that 50 years ago, people had the word interface? Yeah, surprise, surprise. 50 years ago, people had the word interface. Okay? Let's move. Encapsulation. Encapsulation is a bit younger. Encapsulation started probably with the Simula programming language. It was a programming language that was created for Simula was created for simulations. Why you call a programming language Simula? Because it was created for simulations. Okay, Alex, do you agree?
Sometimes, you know, copywriting is a different profession, you know.
Okay.
The C language was called the C because it was after A and B and before D.
Yes.
And encapsulation was first defined in Pascal, but let's not go into those details.
Okay. So
yeah.
in Pascal, you had the concept of a record.
Yeah.
You had the concept of a record in Pascal. So encapsulation is the translation of information hiding in the world of object-oriented programming, in which a class is separated from its implementation. The interface of a class is separated from its implementation. Okay? It is also related to the concept of abstract data types. And there was this concept, ADT, abstract data types, which is also from the 70s. Then we reached the 90s. And the 90s, there was this French friend of mine, Bertrand Meyer, that I met him personally several times. He used to come to Israel very frequently. I don't know if he still comes to Israel. It was very funny. Once I was in my building in Neve Sha'anan in Haifa, and I was going down in the stairs, and who I meet? Bertrand Meyer in my building. And I asked him, what are you doing here? And then he said, you know that lady, that French lady? She's my relative. So I came to visit her. So I met Bertrand Meyer in my building in Neve Sha'anan in Haifa. So the open-close principle, you know it already. Say software entities should be open for extension.
Hayim, it's much better living in Haifa than in Kiryat Yam.
Yeah, Uri is trying to convince me to live in Haifa. But Uri, in Haifa, you don't have Khachapuri. You don't have Khachapuri in Haifa.
We do have in Neve Sha'anan, there is a Khachapuri place.
Original Khachapuri?
Yeah.
Yeah, and with guys, you can move to Netanya. You have both the French guys and the Georgians and whatever you like. So that including
Actually,
Hachapuri.
in Netanya, there's a very good Libyan restaurant.
So there are a couple of good restaurants. One of them is Georgian, one of them is Italian, and lots of different types. But not speaking about that. But real Hachapuri, you can get in Deda. So if we're talking about that, and at least with you guys, Haifa and Kiryat Yam, Netanya, they tried to. For the first time, it was alarm in Netanya, and then we eliminated Hezbollah, Nasrallah. So Netanya with all the Riviera. Yeah, but speaking about but seriously, encapsulation and abstract data typing is definitely started with Nicholas Wirth and Pascal, and that's great. An open-close principle. The next implementation of the same principles.
Exactly. And this was in the Eiffel programming language.
Yeah, evolutionary implementation of the same principles.
Yes, and then we're talking another talk. We can talk about preconditions, postconditions, and design by contract. It was a beautiful concept, very elegant. Design by contract. There should be a contract, a contract between the client of the class and the implementer of the class. So Bertrand Meyer called it design by contract. And to have this contract, this agreement, he said there should be preconditions, and there should be post conditions, and there should be design invariants. Yeah, it was very beautiful, very beautiful. And the programming language that I used in practice that was most similar to that was ADA. The ADA programming language. Yeah, yes, ADA. And ADA, I had the privilege to work in ADA when I was in Elbit Systems. Anyway, when you give a talk after Yom Kippur, people are still thinking about food, right?
No.
Okay, so this example, from my previous talks, you have the strategy design pattern, and now for sure that the strategy design pattern is an example of the open-close principle, because you can extend the context without changing its implementation. Now, let's talk about test-driven development. How test-driven development is related to abstraction. So again, I will not teach you now test-driven development. If you are not familiar with test-driven development, you should learn because it's extremely important. But the idea of test-driven development is that you first write the test and later you write the implementation. So you write the test before you write the implementation. And the only way you can do this, the only way you can write the test before you write the implementation is if you know the interface and the semantics. Yuval, you remember semantics?
Yes.
Okay, so that's something you learned in a previous conversation. Okay, so the test-driven development, we are writing the tests because we already know what the functions are expected to do. Okay, so the unit tests are not fragile. The unit tests that I write, they don't change. What is changing is the implementation. Okay, so I'm not supposed to change the test because the semantics and the interfaces are not supposed to change. Okay. Then inheritance hierarchies. Again, it's the same. We have a hierarchy of classes, and the classes that are near the root, they are more abstract, and the classes that are on the bottom of the hierarchy, they are more concrete. So these abstract classes near the root of the hierarchy should be more robust because they are more abstract. And the classes that are on the leaves, they should be more fragile. Okay? So if I need to change something, I will change the bottom of the hierarchy. I do not change the top of the hierarchy. Okay? Again, if you're not familiar with inheritance hierarchies, go study. Frameworks. Frameworks are the same idea. So a framework is a way to provide you reusable code that you can reuse. And the way you provide you reusable code is by having classes that you can extend. You can extend the framework by creating your own subclasses. So you implement your own details. These implementation details are fragile, but the framework should be robust, should be resilient. Okay, so the framework should be more abstract, and your concrete implementation details should be more fragile. You understand the separation? Okay, another example. So here in this table, I make the summary. So dependency on interface is robust. Dependency on implementation details is something bad, is fragile. If I am a client of an encapsulated class, this is robust. If I am a client of a class that has public members, this is bad, this is fragile. If I have classes that may be extended without modifications, this is good, this is robust. If I have a class that needs to be modified, this is bad, this is fragile. Unit tests are robust. Implementation of the classes being tested are fragile. An abstract class is robust. A concrete class is fragile. A generic framework is robust. Application-specific extensions of this framework are fragile. Okay, so here you have a summary of all the examples that I showed you before. Let's summarize. Software systems are subject to volatility in the form of changing requirements. Concrete implementation details are fragile, and they are affected by these changes in the implementation details. A barbell strategy defines concrete details as a specialization of higher level abstractions. This is in the case of software. The abstractions should be robust and resilient, and they survive the changes. And the details, they change over time, but the system structure and organization is preserved because it's based on abstractions. Do you like it? Any question? Okay, so this should be intuitive. This should be common sense. Should be common sense. Now, here is the second part of my presentation that I would leave for another day. In the second part of my presentation, I explain how you can create something that is anti-fragile using parts that are fragile. Okay, this is a very interesting concept, how I can combine many things that are fragile, small and fragile, and create something big that is anti-fragile. Okay, but this is for the next session. Cool. So before we finish, any comment, criticism, question, joke, anecdota? No? Okay. So I wish you all Chag Sameach, Happy Sukkot. I hope you have the possibility of sitting in a sukkah during the Chag. I will not invite you to my house because the situation is very complicated. Yuval, if you want, you can come to my house. Just 1 minute for you, right? Yuval is my neighbor. I don't know who else is in Haifa. Only Dennis. Dennis, perhaps, if you want to take a risk and come to my house in Kiryat Yam. Uri is currently in China. You don't know, but Uri is in China at this moment. George is in Ashdod, right, George?
Ashkelon.
Ashkelon. I mix between you and Tamir. Tamir is Ashdod, and you are in Ashkelon. And Eugene is in Netanya, together with Alex. Alex, you should meet Eugene. You are both in Netanya.
Oh,
Okay, Alex, Eugene can tell you everything about nuclear reactions, and he knows the history of Chernobyl. He wasn't there, but he knows the history. And you have Paula. Paula, are you in Holon or Bat Yam?
I'm in Holon, but my synagogue in Jaffa, my religious family in Harish, and friends in Beersheba, so I have a lot of things to do on holiday each time.
Amazing, amazing. So look, we'll keep in touch. I really love this. Thank you, Paula. I really, really love this. And I will keep you informed about my plans for the holidays. I will take vacation. I will not work, Bezrat Hashem, with the help of God. I will not work on Hol HaMoed Sukkot, but I may go to Jerusalem. I may go to some other beautiful places, depending on the situation. I will let you know. Perhaps you can meet. Perhaps you can meet in Jerusalem. Perhaps you can meet. You know, it's a big mitzvah. It's a big mitzvah.
Guys, it's after 10:30 here, and I'm exhausted. So good night, happy Sukkot, and see you afterwards. Bye. Dennis, we'll talk tomorrow. Bye.
Toda, Uri.
Bye.
Okay, so let's finish. I also need to go. I have a special event today that was invited, and I need to be ready in a few minutes. So also I need to go. I hope you enjoyed this talk. Do you have any comment, any question? No? You can see the slides. The slides are on my blog. If you go to my blog and you search for Antifragile software design, you'll find the slides. And also you have this talk in Hebrew. If you go to my talks, by the way, I want to show you something that I did today. Is this the last thing I will show to you? Today I had a time because I was trying to recover from Yom Kippur. Yom Kippur is very difficult for me. The day after Yom Kippur, I don't feel well. I feel a bit sick. So this is from my blog. And here, I have here on my talks, I decided to make the life easier for you. So I reorganized my talks. So here first you have in English. These are my talks in English. Then you have all my talks in Hebrew. Then you have all my talks in Portuguese. This is for Jorge. Okay, Jorge, here you have all my talks in Portuguese. Then you have 2 in Spanish and 1 in French. The French actually is an interview. Okay, so if you want materials to study during your holidays, you have at least here in English and in Hebrew. You have lots of things. So here, see, you have the Antifragile software design. And if you come here, you have the slides. You have all the slides here, okay? And also you can visit here, my friends. This is the International Association of Software Architects. And here you can see the events. You have most of the events are in Hebrew. Some of them are in English. There's something that's very interesting. Do you know Therese? Eugene, do you know Therese?
No.
Paula, you know Therese?
If it's actually in Russian, the same. So I think yes, I've heard about it.
Yeah, Dennis, do you hear about Therese?
Yes, of course. Yes,
No,
I
did
see
not.
here explanation. Yes,
So Therese, we had this person here, Vladimir Petrov, who is a Therese master. Wait, let me see it. Okay? Did you hear about this? This is amazing. So I'll send you this link. Okay? I'll send you this link. This is something you need to learn. Please learn this. This will change your life. I'm not kidding. No, I'm serious. I'm serious.
Prisoner's dilemma is also one of the example of how to solve. No, I just checking if I can remember something from this topic.
They have a matrix. They have contradictions matrix. They have 40 principles. They have 40 principles. Okay, so I'll send it to you. Okay. Yuval. Also, you should learn it. I will send it to you also, Yuval. Alex, you know about trees, right?
Sorry?
Do you know about trees?
I know about trees as well.
Yes. Okay. So I will share with our young friends. Also, Eugene is among our young friends today.
Young friend. Okay.
Okay. So, guys, thank you very much. And if you need materials to study, just let me know. I will give you materials to study. Okay? Don't be shy. תודה רבה.
Thank you
תודה
very
לכם.
much.
Thank you. ספסיבה большое.
ערב טוב.
Bye bye.
Thank you, Chaim. Bye.
Bye.